Alright, 2007 question 4, which is non-calculator. So part A, the time at which it's farthest left would be the minimum for this function. Since we're given the position, we need to find the derivative. And notice that we do need to use the product rule to find this derivative. And that's our derivative. Then we need to find the critical points to find the min, so we set it equals 0. And I'm going to factor out e to the negative t. So e to the negative t will never equal 0, so our only solutions will come from when cosine t minus sine t equals 0, which would be when t is pi over 4 and 5 pi over 4. And what happened here with that? So now I want to figure out which of these, if any, are possible mins. Remember, our interval here is 0 to 2 pi. So I evaluate the derivative between 0 and pi over 4. It's going to be positive. In between these, it'll be negative. And then positive between 5 pi over 4 and 2 pi. So a possible min would be at 5 pi over 4. That's the only possibility, but we also have to check the endpoints. So now we need to actually find the position when t is 0, the position at 5 pi over 4, and the position at 2 pi. Well, sine of 0 is 0, so this whole function will be 0. Same for 2 pi. So really all we need to know, since we're looking for a min, is whether or not 5 pi over 4, if the original function will be positive or negative. And at 5 pi over 4, the sign will be negative, so this will have a negative value. We don't even actually have to know what the value is. So we know it's farthest left. At t equals 5 pi over 4, because that is the minimum for x of t. Okay, part B. We need to basically fill in this equation. So you notice I need the second derivative. I already have the first derivative and I need the original function. So I'm first going to find that second derivative. And I get doing a bunch of product rules. And this works out nicely because I get a lot of like terms, which when I combine them will make 0. And these two will combine, so basically my second derivative is negative 2e to the negative t cosine t. Now I have everything I need to fill in this equation. So I'd have negative 2a e to the negative t cosine t. Now the first derivative, e to the negative t cosine t, and the original function. And where does that equal 0? Well, again, we get some like terms here. They make 0. And these two like terms, I can, not here, right here, I can factor out e to the negative t cosine t. And then I'm left with negative 2a plus 1. Remember, when we're trying to find a, so the value of a would be whatever makes this equal to 0, which would be a equals 1/2.